All right, we're back. Okay. Good morning, Patricia. How are you? I hope you're doing well, Patricia. What section are we working on today? So we're going over the last part of section 2.8. We're going to be doing 3.1 and most of 3.2 here today. So those are the three sections that'll be on the docket here. Really, it's not a lot of 2.8, so just understand we're going to pretty much get through that rather quick. Um, 3.1 and 3.2 are the main sections today. Carissa, good morning. How are you? Good and tired. I'm doing good. Did you go to bed late last night? Or were you just up like doing homework or something? A project maybe? I don't know. Sounds like you had a really busy day. Oh, you had to work last night. Oh. Oh, okay. One of those nights where you just have a lot of energy, can't really go to bed until like early in the morning. I understand that. Sometimes your body doesn't agree with what you want to do. Sometimes I just lay in bed and be like, I just tell my body, I'm like, yo, bro, I need you to, I need you to go to bed for me. I need you to shut your eyes and go to sleep. My body's like, no, 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 man. It's all good. You can just lay here. No problem. And I'm like, man, that sounds like a good idea. Let me keep going. Good morning, Sion. How are you? and then eventually, Robert, good morning. And then eventually, how are you? Eventually, you're on your phone or you're on your tablet or your laptop or something. You're just watching like YouTube videos in the middle of the night for whatever. And then finally, you fall asleep in front of your phone or tablet or whatever. So it's like, well, okay then. Finally, you're ready to go to sleep. What's poppin'? What's poppin' is this class. That's what's poppin', bro. Um, I'm doing great, Robert. I hope you are doing very good. I hope you're going to have a very good weekend because it's weekend time after we're done, right? So, that's pretty good. Gonna have a little fun. What's fun to listen to on YouTube? What's that? Mr. Nightmare. Good morning, Hisa. How are you doing? Good. I hope so. Let me get a Mr. Nightmare just sounds bad. um Here, I got let me do this. Let me do this. I do this in my other class, but just for a small little snippet here, then we'll get started. So we're gonna go with
If you like the super, if you like the super, dance with me. Super E, super B, we can move the beat or we can start this crazy night. Tonight we start. We can dance and move, we're ready. Now let's change the world. Super Eurobeat, like a music fight. You can make it right. Super Eurobeat, you're the supersonic ecstasy. Super Eurobeat.
All right, enough of that. Okay, okay. Let's get back to doing real things. All right. All right. You said you wanted to wake up. I'd be like, here you go. Here's some wake up music. Okay, we'll just put on some Eurobeat music. Pretend that you're drifting. You know, there you go. Now you got it. Oh man. Okay. Okay. That's fair. Okay. All right. So let's do the real things. All right. Okay, let's get started for today. Welcome back to Thursday, end of the week time today. So today, we're gonna finish up the last part of section 2.8, doing a couple of word problems there with multiplication and division using mixed numbers. All right, in applications, and then we're gonna get right into chapter 3, the first couple sections here, which is talking about adding and subtracting some fractions, and then talking about one concept that we'll need for additional adding and subtracting a fraction. So we're going to talk about those guys there once we get to it. All right, so let's go ahead and get going here. So uh, we're going to start here at the very end, at the tail end of the last section. We did talk about multiplication and division of mixed numbers there. And we saw that you have to go ahead and change it over to an improper fraction first. Go ahead and apply our multiplication or division rules. And then we go ahead and then we say, all right, we just use the rules and then we multiply straight across once we've reduced stuff down, and then we got our answer. All right, now in this particular case, let's take a look at a couple of examples here, and let's see how we can take a look at the keywords here in each of these cases. So let's look at number 3. The local Habitat for Humanity chapter is looking for 11 contractors who will each donate 3¼ days of labor to a community building project. How many days of labor will be donated in all? Now, one thing that I don't like about this, it says applying division skills. Really, it should be multiplication and division. So We talked about keywords previously regarding multiplication, and in this particular problem, there is another keyword here for multiplication. And how do I know I'm using multiplication here? It says each person. Each person is giving, in this case, 3¼ days of labor. Okay, so 3¼ days of labor. Each person is individually giving that much amount of time. It says how many will be donated in all. Okay, so basically the total here. Okay, so if you want to kind of think of total, we also are using total usually means sum, but again, because there's 11 people giving the same amount of time, okay, we can multiply in that case. Okay, so let's take a look on how we can figure that out there. Okay, so you're not supposed to go to my second screen. All right, there we go. Okay. So in this particular case, let's go ahead and take 11 and we'll multiply that by 3¼ Hey, Rohan, how are you, my friend? All right, so we want to convert 3¼ We want to convert that into again, a improper fraction. So we're going to take 3 times 4 plus 1. We'll put that over 4. So again, this is going to be 13/4. So we're going to have 11, and you can put that over 1, times 13/4. Good, my man. Good. I hope your day is going well so far. Nice and shiny out, hopefully, where you're at. All right, now, unfortunately for us here, there's nothing in common that we can pare down here. So unfortunately for us, 11 doesn't go into 4. So we can't really reduce that down as much as we want. So we just multiply straight across here. We get 11 times 13, which is 143. We get 143/4. All right, so here we have 143 divided by 4. We have 3. Okay, so 4 goes into 14 3 times. So we have 12. Which problem am I doing, Samantha? Is that your question? I'm doing an example number 3 here, this one. I'm just doing multiplication, in this case, of mixed numbers. And now I'm converting this answer back into a mixed number. That's what I'm doing here. So I'm just kind of showing out the steps about how to do that. So I bring down the 3 here. So, well, that's not good. All right. So 23, 4 goes into 23 5 times. How did I get, oh, yes, that was converting the mixed number here. So remember, that was converting the mixed number into an improper fraction. So that was that rule that we talked about a while ago. So remember, it's the same thing as if I had 2 3/5, right? You have to convert it to an improper fraction. You have to take the 2, which is the whole number, times the denominator, which is 5 in this case, plus 3. And you got to put that all over the denominator of 5. So that's what we did there for that case. So that's how I'm getting the 13/4 here, or in this case, I'm getting, like in this case, 13/5. So I wanted to convert it into into an improper fraction first before doing the multiplication. Nice, my dude. Looks like Rohan's having a lot of fun out there. I love it. All right. So here we get 35 3/4 here. Okay. And this here will be our final answer for that problem. Any questions about that? I hope that I cleared up your confusion there, Samantha. All right. Well, let's go ahead and I'll put up this canvas here a little bit bigger. All right. There we go. All right. Let's look at the next problem here then. Where are you? Okay. So the next problem here, we're going to go ahead and give example 4 a try. It says a dome tent for backpacking requires 7¼ yards of nylon material. How many tents can be made from 21¾ yards of material? So here's another keyword for division that I noted here. Okay. It says how do I know what we're doing division here? It says how many of something, say in this case, how many of something can be made? So we have a bunch of material here, a bunch of this material here to make this uh, tent, okay? And we have to divide it up so each one of these tents here uses a 7¼ yards of that particular material. Now we don't know how many tents that's going to make, but we have to divide it out just to see how many we can put together. Okay, so let's do some division here. So what are we dividing? We're dividing in this case the number of yards of material we have total, and we're going to divide it by how much it takes for each tent to be made. So what we're going to do here specifically is we're going to have 21¾ and we will divide that by 7¼ Okay, so we're just going to divide those guys from each other. Okay, let's go ahead and convert each one of these numbers here into improper fractions. So let's look at 21¾ first. Okay, so can anybody tell me what is 21¾ as a improper fraction? Uh, 29/4? Oh, well, I will say, Sion, I totally agree. 7¼ is 29/4. That part is definitely true. I think you're a little bit ahead, uh, but respect nonetheless. 87/4, that's correct. So to get 87, take the 21, multiply by 4, add the 3, put that all over 4. And that's correct, 87/4, spot on in that case. And 7¼ as Sion pointed out, 29/4, that would be correct as well. So let's write out our division problem here. So we have 87/4 divided by 29/4. So that's what we have here so far. Okay, now, how can I rewrite this division problem here? What should I do? How can I rewrite this problem? Don't forget division of fractions here. Okay, very good, that's right. So if we rewrite this in terms of a multiplication problem, we get 87/4 times 4/29. Good. All right. Everybody's spot on so far. Now we want to see if we can reduce things down. Now, two things we can automatically reduce is we have a 4 on the top and a 4 on the bottom. So we could divide both of those by 4 and effectively cancel each other out. So that's fine. Now, there are usually two things that happen after this. So let's at least talk about that. after this point, you probably could go ahead and just say, all right, I get 87 over 1 times 1 over 29. And so here you get 87 over 29. Now, if you did this out and you say, hey, I want to make this into a mixed number, what you'll realize actually is that 29 does go into 87 exactly 3 times. So the answer here is going to be 3, exactly. That's correct. Let me move this around a bit. Sorry. Yep. Good, good, good. Nice. All right. Make it a little easier to see for you guys. All right. Okay. Any questions about that problem there? Again, the reason why, if you don't see that you can divide 29 on the bottom and top right away, that's why we'll just go to, you go to the mixed number approach and then do the same thing, and you'll find out you'll get exactly 3. So no. Okay. All right. All right, cool. All right. So so that's pretty much what I wanted to talk about here in 2.8. It's very quick and fast, okay? Those are the 2 examples I kind of wanted to focus on there in that case. I lost you a long time ago? Like, how long ago? You can go to my office hours, that's fine. We're gonna, oh, okay. that was a little while ago. Well, happy to answer any questions for you during office hours. That should be fine. Okay. Let's take a look here at so we're going to skip that. All right, there we go. All right, so now we're going to move into chapter 3. Now, the reason why I'm going to have chapter 2 and 3 kind of go together is because really a lot of the concepts that we talk about back in chapter 2 is going to be definitely applicable here in chapter 3. So let's talk about, in here, we're going to talk about adding and subtracting fractions here in chapter 3. So the first section here in section 3.1 is talking about adding and subtracting like fractions. So the question is, let's take a look here. So when we add or subtract like fractions, what are like fractions? Okay, what's the base definition of what like fractions are? So like fractions are fractions that have the same exact denominator. So they have the same denominator. So again, that's what we're going to be keying in on here in this section is what happens when we have the same denominator between fractions and what can we do with them. Okay, so for example here, let's take a look at our examples over here. Well, sorry it bores you, bruh, but that's not my problem. All right, so as you can see here, we have the same denominator for each one of these fractions. So we got, 4 is our denominator here for every single one of our fractions in this instance. However, in this case here, we do have unlike fractions because we got different denominators here of 12 and 7 respectively. Okay, so those are unlike fractions since they do not have the same denominator. Okay, and why is that, Fish? Okay. Sometimes we have to do hard things to get better. All right. So let's take a look at the steps here to add or subtract like fractions. So I put a couple of rules up here. So the first rule here says, let's say we have A over C plus B over C. Okay, so as you can see here, we have the same denominator here of C. Okay, well, whatever that number is, we don't really care. But that's going to equal a plus b. We're going to add the numerators here just straight across, but keep the denominator the same. All right, so we're going to add straight across with the numerators, but then keep the denominator here the same. Okay. And we do the same thing here with subtraction. We have, again, if we have the same denominator here, we have like fractions. We just go ahead and subtract straight across, and then go ahead and keep that denominator the same. Okay, so let's take a good look here at several examples about how to add or subtract fractions. And we're going to go over each one of these steps here. So step one, we're going to confirm that all the fractions have the same denominator. So that's one thing that we have to confirm right away. If they have the same denominator, same number on the bottom, okay, you're good to go to with the rest of the problem. Step two, add or subtract the numerators straight across and keep the same denominator. So like we mentioned here, we're going to add or subtract straight across, keep that same denominator. And then finally in step three, we're going to reduce as necessary. So it may be necessary for us to reduce that fraction into its lowest terms. Again, homework problems will kind of ask you to put it into lowest terms as necessary. All right, let's look at some problems here and let's work them out. All right, so we're going to go over each of these here. Okay, so this one here, pretty straightforward. Again, we're just going to go ahead and add our two numerators together. So we get 1 plus 2. That's correct. And we keep the 5. And that's right, Patricia, we indeed get 3/5. So 3/5 here, pretty fast and simple. All right, doesn't require too much work. All right, pretty straightforward. Let's try the next one here. Next one here is on the handout. Okay, so we have 1/12 plus 7/12 plus 1/12. So again, we'll add the numerators here straight across now that we have all the same denominators. All right, excellent. Good, good. All right. Now, I agree with both of those answers there, 9/12. Now, remember the last part here. Remember, if it can reduce, we have to reduce here. So let's take a look at this here. Does 9/12 reduce? Does that reduce? That reduces to 3/4. Good. That's correct. Okay. Right. So when we get down to 9/12, we have to, or when we get down to anything really, at the end of the problem, we have to ask ourselves, do we have a common factor in the numerator and denominator? And can we factor that, can we reduce it from that number? And in this case, we can. So we can divide by 3 since that's what they have in common. So we get 3/4. Okay. How do you reduce? Again, you have to find the common factor between, in this case, 9 and 12. So can you find a number that both divides 9 and 12? Well, that answer is going to be 3. 3 divides 9, and 3 also divides 12. So I do 9 divided by 3, and I get 3, and I get 12 divided by 3, and I get 4. So that's how we're able to reduce those. So those factors that we talked about from before will certainly be helpful here. Can you reduce it before adding them? Excellent question. The answer is no. Actually, you cannot. Um, It is, and it's because of addition doesn't work like multiplication. Okay, so addition subtraction do not work like multiplication, so we cannot reduce them before we add them. What we'd want at the end of the day here, Sion, is essentially we want all the denominators, all right? We want all the denominators here to be exactly the same. Oh, yes, I forgot to make that announcement there. Apologies, Jacob. I will be looking over your test here on the weekend, so you should see a grade on D2L this weekend. So, thought I made that announcement. That was just my first class. So, yeah, that'll be graded this weekend for sure. That is definitely on my priority list to do. Okay, so yeah, always reduce at the end as reduce at the end. So for adding and subtracting, we'll reduce at the end. So multiplication you do before, but add subtract you do after. And to make it as easy as possible. Yes. Chapter 2 and 3 will be the next test. No problem. Okay. Any other questions before we move on? We're going to do some more examples, of course, but just making sure. Okay. Let's go ahead and try another problem here. Okay. So let's go with let's go with so let's go with 13 over 16 minus 3/16. Okay, so here we're going to do some subtraction. All right, so we have 13 over 16 minus 3 over 16. Okay, so not going to do anything different. We're just going to subtract. Okay, and what do we get here? 10 over 16. Okay, that's good. That's good right there. Now, can 10 over 16 reduce? Is there a common factor between both of those numbers? Five over 8. That's correct. 5 over 8. So we're going to take both of these numbers here can be divided by 2 since they're both even numbers. 10 divided by 2 is 5. 16 divided by 2 is 8. All right, so 5/8 there is our final result for that problem. Good. Let's I'm gonna just kind of sneak a peek here. No. Okay, yeah, right. Okay. Let's go ahead and do another. So let's do what I do. What is the 2? I divided both the top and bottom by 2 because that allowed me to reduce the fraction. So that's what the 2 is there for. Since 2 goes into 10 and 2 goes into 16, I can divide both by 2 and reduce the fraction down. So let's go with Okay. All right, so we have 17 over 20 minus 1 over 20 minus 9 over 20. And what will that be? Want to just, again, subtract the numbers on the top directly. Keep that denominator the same. Okay, so we get 7 over 20 here. Good, that's right. So here we get 17 minus 1, 16. 16 minus 9 is 7. Get 7 over 20. Now 7 over 20 does not reduce. Oh no, that's cool, dude. It's all good. Much love in the neighborhood. All right, so that's our final answer for that. Okay. Any questions so far about addition and subtraction of like fractions anyway? Okay. No? Okay. Now there are a couple more examples that I have to do, which are rather important. So a couple other examples here will be in relation to either adding or subtracting with mixed numbers. You need coffee. It sounds about right. Hey, look, it's like the brain fart there. I'm trying to stay away from coffee, but I love me Dunkin' Donuts sometimes. So can't really argue there, you know. Let's go ahead and do some more examples here. All right, let's do it with some numbers here we can add or subtract by with improper fractions. So let's say we're doing 17 over 5 minus 3 over 5. Okay. Hi, Parrish. I'm uh I'm doing I'm doing pretty good. How are you? All right. So we have 17 over 5 minus 3 over 5. And that's correct here. We're going to have 17 minus the 3 here over the 5. All right, and that will certainly be 14 over 5. Now to get our mixed number here once again, we're going to take 14 divided by 5. That goes, 5 goes into 14 2 times, and Patricia, you're absolutely right. 2 times 5 is 10, and this confirms her answer here. Yeah, we're doing some fractions here. So just covering some of the basic concepts of how to add or subtract fractions is where we're at right now, Parrish. All right, so we have remainder 4, so that's 2 and 4/5. At least this will be a basis for what we'll be doing later. One of the basics, I should say. So we do get 2 and 4/5 here as our final result for this answer. Okay. Let's try it with some addition as well, because that's certainly plausible. So let's do 29 over 7. Cool. I'm glad you like it. A lot of people say that to me. I don't know how you found this channel, but hey, okay, cool. Hi, Christian. I hope you're well. Let's do 3 over 7. Fine. All right. Here we go. Let's just say we're in our own little corner of Twitch. I think that's just fine. All right, so adding these together here, you get 29 plus 3 over 7. Here we're going to get 32 over 7. That's correct. Now, we want to change that 32 over 7 into a mixed number. Because again, some of the problems will ask you for a mixed number there as part of your answer. So how could we write 32 over 7 as a mixed number? So how many times does 7 go into 32 here? All right, that's correct. Very nice. All right, so we have 4. Spot on. All right, so 7 times 4 is 28. And we got a remainder of 4 here after we subtract. So 4 and 4/7 is absolutely correct. Nice. Nice job, everybody. Nice work. All right. All right. Great, great. All right. Any questions about that so far? Nice. I thought you were following me, Samantha. Oh well, no problem. I had to do it. I had to do it. I had to do it. I had to. uh, Somebody says you do try very hard, Samantha. You do. That's why I love your effort there. Your effort is your effort is definitely to be commended. That's why I'm here to help. Oh, okay. You hit the wrong. Fair enough. I'm like, what did I do to deserve this? I don't understand. Oh man. It's all good. It's all good. I don't trust me, I won't take offense to anything like that. So no big deal at all. No big deal. It's all good. Now people like unfollowing, following, just hitting the button. You know what? You know what, Samantha? Maybe today is not the greatest day in the whole wide world. But remember, it's progress in the right direction. At least you're trying. And that's all that counts. It may not be what you like, but at least it's positive toward that direction. I'm cool with that. Some days are never going to be easy, even for me. Some days are just not easy where I'm just kind of exhausted and tired. But you power through it because you know what? There's a bigger goal in mind at the end of the day. And I think that's okay. And then once you're done, you you go to sleep there. You're like, relaxing time, and you're like, man, feels good, dude. And that's, you know, lots of feels good man sort of deals. Absolutely, 100%. Oop, sorry. The right direction leads the right path. This is true. Um, although, just remember, uh, the right direction for you is different than the right direction for someone else. You'll define that for yourself. So, and that'll be the right path for you at the end of the day. Just obviously don't hurt yourself or others in the process. As much as you can, of course. All right. Let's go to, where am I here? Indeed. All right. Okay, next. We're going to go over the next section here. We're going to do a majority of this next section here, which is talking about least common multiples. Okay, so let's talk about least common multiples. Thanks, guys, for the follows. I appreciate that. Okay, so let's take a look here at what least common multiples are. Now, least common multiples are something you may have heard before. All right. Yeah, the stream is a little delayed, so I'm not on the loss list. I'm on. I need better bandwidth, so um, yeah, that's why the stream is a bit delayed there. Yeah, just being as transparent as possible. That's why the stream is always delayed. My bandwidth can't keep up unless I like purchase somewhere. So, and I'm a one-man crew, so you know, as long as I get the point across, and that's cool. And these guys can still answer. That's why I may always make adjustments there. So, all right. So let's talk about least common multiples. Now, least common multiples here, you'll see me write LCM for least common multiple. Now, the way we talk about least common multiple here is what's the definition? Now, put the definition here is the smallest multiple in common between all the indicated numbers. All right. So all the indicated numbers here were, whatever numbers were given here, all that, Army one. All those guys, we're going to find the smallest said multiple between all of those numbers. Now, let me go ahead and before I explain why I've crossed out the word smallest here, I'm going to ask a question here on chat. Okay. So, what do you think the least common multiple is between 2 and 8? What is the least common multiple? What is the LCM between 2 and 8? Okay, I see 2s. Anybody else? 4? Okay. Anybody else want to chime in? Please go ahead and do so. I want to see most everybody's answer here, so. Okay, anybody else? What's the LCM between 2 and 8? I see a bunch of 2s. I see a 4. Anyone else want to chime in? And I'll let you know. Okay. So, let's talk about the LCM here. So the least common multiple between 2 and 8 is 8. So all the answers are wrong. Hey! All right. And let's talk about why it's 8. Let's talk about why it's 8 and why it's not 2. Yes, definitely a question about why, because we definitely need to talk about that. Absolutely. So first, let's talk about a little bit about psychology here for just a second. The reason why people get confused about this concept is because for least common multiple, the first thing that you think about is the word least. When you think about the word least, you always think of the word smallest. And when you think of the word smallest, you think of the smallest number between the numbers, which would be 2, right? So we're not trying to find the least common factor. Look carefully. We're trying to find the least common multiple. But as I put here, it says smallest multiple in common. Now, I took away the word smallest because that is not the mindset I want you to think in anymore. Okay, when we think about the word least, we no longer are wanting to think about the word smallest. So we want to remove that psychological barrier. And trust me, you're not the only ones to answer 2. Okay, pretty much everybody in the last class also answered 2 for the same exact question. So trust me, it's a very common thing because of that kind of tendency to think smallest, pick the smallest number, and then that's your answer. So I put a very important keynote here to actually understanding what a least common multiple is, or what it should be. So this is the big note here, and I'm going to make this even bigger because this is how important this is. If you want to understand how to add and subtract fractions, this is this is definitely one half of the problem right here. The least common multiple here between numbers is always the biggest number or higher. So you always go the biggest number or higher. That's going to be the least common multiple. Okay, we'll look at some examples here as I did that. So always choose the biggest number. So if I chose between 2 and 8, I would choose 8 to start with and any multiples of 8 after that. So that is where the mindset needs to be. Pick the largest number now and go up with those multiples and see if it works. Okay. Let's try one. Well, let's try a few actually. Let's try and at least understand how we can find the least common multiple here now that we have this big keynote here. So let's try and find the least common multiple here between 4 and 6. Okay, so in this case, we would start at 6. That's correct. The answer is indeed 12. So one thing you start at 6, okay? You start at 6 and you say, okay, well, obviously 6 divides itself. That's pretty obvious. But does 4 divide 6? And the answer is no, 4 does not divide 6. So I tried the next multiple of 6, which is 12. All right, 6 divides 12. That's pretty easy. But does 4 divide 12? And I would say, yeah, it does. So 12 would be my answer for that. So that would be my least common multiple. Okay, let's look at another example here. Okay, let's try, all right. How about 10 and 12? How about 10 and 12? What would be the least common multiple between 10 and 12? Okay, so you get 60 there. All right. Okay, so let's take a look here. Let's go through the process here. That's right. So let's start off with the biggest number here. The biggest number is 12, okay? And we're just going to ask the same question here. Now, this number will obviously divide itself, but we're really looking at the 10 here. The 10 is the bigger one. So 10 does not divide 12. So we take the next multiple of 12. Add 12, we get 24. Does 10 divide 24? No. I'm going to need to keep going. 36. Does 10 divide 36? No, unfortunately not. So we keep going. We get 48. Does 10 divide 48? The answer is no. Go up one more step here. We have 60. Does 10 divide 60? Yes, that divides 60 nice and evenly, and that's going to be our LCM here, our least common multiple of 60. Any questions so far about those two examples? We'll move to a tougher example here, but just want to be sure everybody's kind of on board about the process here. The thought process is important. So, least common factors. Least common factors are the smallest factors, so the smallest numbers in common. So this is okay. So there's a difference of wording there, right? I agree. That's where people get messed up here. Remember, this is least common multiples. Okay, so a multiple of a number. A factor is if you break it down into smaller numbers. So that's why I put the key note here is the biggest number or higher, so you know you're not going down, you're actually going up. That's correct, Carissa. Yes. The highest said number, the least highest said number, least multiple, or the highest said number that both can go to evenly. So you can start at 12 and then kind of work your way up like in this problem here. Yeah, I want to make this particular concept here is really hard at first because again, you've been psychologically tricked to go the other way. So, and because it sounds similar to other concepts, it's like, okay, um, we have to kind of rewire the stuff there inside the head. Even when I did this for the first time, I was just as confused. So, yeah, I totally understand where you're coming from on that. All right. Let's try another one here. This one is from the book, so I'll just kind of go down there. Where is it? There it is. Okay, so we're going to do this one right here. 5, 6, and 35. Okay. Go ahead and take a minute here. See if you can find the least common multiple between 5, 6, and 35. Take a minute here just to hopefully get this one. Okay, so Patricia says 210. Let's take a look at other guesses here, and we'll look at the answer here. All right, 210. All right. Okay. Well, let's take a look at our answer here. All right. So even if you didn't get it right now, that's fine. For some of you, it may take a little more time. So that's not a problem here. Okay. That's not a problem at all. Okay. You guys will take things at your own pace. I'm just going to show you my thought process and then see if we arrive at the same result. So I'm going to do the same process I did in the last two examples here. So I'm going to start off with 35. And with a start off at 35, now 5 divides 35. However, 6 does not divide 35, unfortunately. So unfortunately for us, 35 is out. So we pick the next number up. Again, we're picking the biggest number and taking its multiples. So we take 70. All right, 35 and 5 work with 70, no problem. However, once again, 6 is a roadblock. It doesn't divide 70 evenly. All right, next is 105. 35 and 5 once again, perfect with that, but 6, unfortunately, still in our way. Well, that's not good enough. Let's try 140. That's the next one up. 35 and 5, perfect, but 6, if you try it out, 6 does not divide 140 evenly. We'll try 175. 175 works again with 5 and 35, but unfortunately still a no-go with 6. And then we try the next one here, 210. And 210 does divide with 35 and 5 pretty easily. And yes, indeed, also divides, 6 does divide 210 here. So in this case, our least common multiple here will be 210. All right, so 210 is the correct answer. Any questions about that so far? Nah. All right. Okay. So the one thing, all right. So there is one issue with this process, and that is there's a lot of kind of writing and, a lot of multiples that we have to check all the time to see if it fits with the other numbers and whatnot. What if there was a slightly better method or faster method to actually find 210, like in this particular example? Yeah, because that's a lot of numbers you have to kind of go through and add by 35, and that can be a bit of a pain. So we're going to look at a second method here, okay? And we're going to do this out on the paint tool here. So let's go ahead and do that. So let's look at this second method and see how we can actually find the same exact answer in this case. So we know what the answer is. We know the answer is 210, okay? We know that for a fact. Now we just want to be able to replicate that answer with the same three numbers of 5, 6, and 35. So let's do that right now. So we can put 5 and 6 and 35. And we're going to use a concept that we talked about here back in chapter 1. So back in chapter 1, we talked about how to basically factor out numbers, okay? And once again, we're going to make some factor trees here. In this case, a prime factor trees. So here, the second method, the first thing we're going to do is we're going to break up each number into prime factors, and what we're going to do is quote unquote pair off any matches. And I'll describe what that means here in a moment. As you can see some of it already here, but you'll see how it works here in this particular example. Okay, now when we have a pair here, and more importantly, let me move this over to the left. Oh, actually, you know what? I'm going to switch these around so you can read that. Sorry. No. Why? Okay. All right. Okay. So once we circle a pair, and notice I put pair in quotation marks here, of numbers, we only include one number in the least common multiple. Then we multiply any, this should be multiply any single numbers that are left over. So let's go ahead and talk about what that actually means one step at a time here. Okay, so what that means here specifically is a 5, for example, 5 if is its own prime number. So we're going to circle this prime number here since this is prime. Now 6, on the other hand, can be broken down into two prime numbers, that being 2 and 3. So 2 times 3 is 6, and we'll circle those prime numbers. And then finally 35 can be broken down into two prime numbers of 5 and 7. So we're going to circle 5, and we're going to circle 7 being our prime numbers there for 35. Now, having all these prime numbers will be important because what we're going to do is we're going to list them. So we're going to list 5, and if we broke down 5, 5 is just 5 because it's just itself a prime number. 6 here is going to equal 2 times 3. And 35 here is going to equal 5 times 7. All right, so what's the least common multiple here? Okay, now we want to pair off any matches that we see here. So a match that we see here is this 5 and this 5. So these two essentially, quote unquote, they pair off. And that's going to be, again, we're going to put in just 1 5 here for the LCM. Then we check to see if there are any other matches. Unfortunately, there are no more matches. We have 2, 3, and 7 left over. So we're going to multiply that 5 by the remaining 2, 3, and 7. Any single numbers will be just automatically multiplied here into the least common multiple. And if we multiply all these numbers here together, 5 times 2 times 3 times 7, if you do that out on a calculator, whatever, you're going to get exactly our answer here of 210. So we do indeed confirm that 210 here is the LCM of these three numbers. Okay. Are there any questions about that so far? No? Okay. No? Okay. No? All right. No? All right. That's fine. Okay. So let's try another example here. Okay, let's try another example. All right, we're going to pick 3 different numbers here, and then we're going to see what we're working with. Okay, we're going to get our LCM and everything. So, okay. So this one's also on the handout, guys. So we have a 10, I think it was 20 and 24. Yeah, so we're going to do 10, 20, and 24 here. So write out our factor trees here. Okay. So let's break down 10 here first. What does 10 break down into? I agree. 2 and 5. All right. So we're going to, all right. So far, so good. All right. How about 20? So I agree with you, Parrish. We're just going to show off. We're just going to see how we actually arrive at that answer. So, all right. So you could break this down into 4 times 5 or 2 times 10. Either way, yep, they're both okay. So if we break that down, 10 becomes 2 and 5 like the last one. So perfectly fine. 5 and 4 would work too, because then 4 breaks down into 2 and 2. So that's just perfectly okay. Either way, no problem. Nah, it's all good, bro. I have no issues with that at all. We're trying to prove this answer so we can confirm that to be true. So proving it, like the process, is what we're after here. No worries though, man. We're good. All right. How about 24? How about 24? What can we break that down into? 6 and 4. Okay. And 2, 2, and 6. So we get 2 and 2 here. Don't forget 6 also breaks down. 3 and 8 would also work too. You would break down 8 to 4 and 2, and then another, you'd break that down even further. So they're all okay. In either case, in any of those cases, that's perfectly fine. We're going to circle our prime factors here for each number. Okay. Okay. So first I'm going to write down 10 in our list. That'll be 2 times 5. We'll take 20. 20 is 2 times 2 times 5. And we'll also take 24, which is 2 times 2 times 2 times 3. Okay. So this is the breakdown of each of the numbers here in this particular example. All right. So let's take a look at what we call pairing off here. Okay. So I'm going to go back to this here. All right. So we want to pair off numbers here in this case. Now, again, what does pairing off mean? Well, one of the things that we're going to do here specifically is we are going to see, we have a 2 here, a 2 here, and a 2 here. So 2 in the 10, 2 in the 20, and 2 in the 24. So we're going to circle all 3 of those and consider that a pair. So I made a note here. I said a 3 of a kind here is acceptable for a pair. Okay, so I know that that doesn't make a lot of sense in the conventional sense, but just to kind of showcase and say, okay, 3 of a kind still means that we still put one number down for those 3 that we circle all together. Let's take a look and see if we can find another pair. Well, as we see here, we have 2 5s. This is a pair. So we can multiply by 5, and that would be fine. That's another pair. As you see here, we have 2 2s. Here's another pair. So we multiply by 2. Then we have the 2 and the 3 left over. So we're just going to fill in those gaps. And then we're just going to see what we get here. So we get 2 times 5, which is 10, times 2, which is 20, 20 times 2, which is 40, and 40 times 3, which is the correct answer here of 120. Okay. And that's our final answer for that problem. So you can see how the quote unquote, the quote, the air quotes, pair off method, kind of works there. Any questions about that? No? Okay. What makes a pair? What makes a pair is that if you have the same factor in at least 2 of the numbers. That's what makes a pair. So notice I had 2 in all 3 numbers. That makes a pair. Notice I had a pair of 5s, one 5 and 10, and one 5 and 20. That makes a pair. One other 2 and 20, and one other 2 and 24. That makes a pair. So you can see how if I circled things out, I'm effectively making pairs there. Yeah, the prime factorization over the manual is by far a lot easier. I agree with that, Parrish. That's very, very true. Yeah, so if you're talking the homework there, homework is going to be section 2.8 if you haven't done the word problems here yet, 3.1 and 3.2. Okay. All right, cool. Nice. Then you are ahead, my friend. That's good. This is as it says, Math 090. This is pre-algebra in college level. So, we're going over a lot of fundamentals in this class just to build up the math sense back up. For some people it's maybe been a while. For some people, they just struggle with the subject, and that's cool. So, I mean, we're here to help as many people as we possibly can. So, yeah, maybe. All right. All right, everybody. I want to thank you all again. This is where we'll leave off. Next time, by the way, we're going to talk about adding and subtracting fractions. So we're definitely going to use this concept here for next week. So next week is going to be a very, very big week in terms of understanding how to work with these adding and subtracting of fractions of some variety. When's the test? As soon as we're done with chapter 3 there, Hisa, we will be done with that material. That's when I will make the announcement for the exam. So not for a little bit yet. Thank you, Carissa. You too. You have a wonderful weekend as well. Yeah, so I wish, as Carissa just said, I wish everyone a very great weekend. Okay, uh, you know, you're always welcome to participate, Parrish. Don't worry about it. It's all good, my friend. It's all good. At least everybody's here to learn or learn something about themselves. It's all good. You know, that's what it's about. So anybody's welcome as long as you're respectful, and I know you're respectful. So yeah, no worries, my dude. Nothing wrong with that at all. Have a great weekend, Robert. You have a good one. Patricia, thank you. Thank you for coming out today. I appreciate your time and energy for coming out to the lectures. I really appreciate it. You guys put in a lot of hard work. Thank you. Thank you again. You have a great weekend, Martin. Relax and enjoy yourself. Get a little stuff done. Uh, we'll be good. Does anybody else have any other questions before I head out? All right. Very good. Okay. Well, take care, everybody. Have a great weekend. We will see you back here on Tuesday. Tuesday, Sion, thank you. Thank you very much for being a very, very wonderful, wonderful student and a very wonderful, wonderful person, and being a hard worker as well. What else do I teach? I'll teach college algebra. I teach technical mathematics. Um, I teach quantitative literacy as well. I've taught many other classes besides those, but those are the ones for this semester anyway. So stats, intermediate algebra, pre-algebra, trigonometry, calculus 1. Yeah, pretty much go up to calculus 1. So I haven't taught linear algebra. Well, I mean, I know of linear algebra, of course. If I haven't taught linear algebra before though. No. I've taught business math and I've talked about simplex method before. And that's a little bit of linear algebra technically. Um I know how to, of course, if you want to talk about matrices, I know how to do matrices. But of course, linear algebra has a lot more to do with matrices. It's just a lot of concepts behind that, like eigenvalues, eigenvectors, delta and stuff like that. I haven't done that in a long time. That was one of my favorite subjects, though. You're stuck on matrix equations. Oh, I see. What kind of matrix equations are we talking about here? Like adding or multiplying matrices? Or what's the story? Ah, okay. I gotcha. You know, that's actually not as bad as you think, okay? Let me show you what I'm talking about. Yeah, yeah, yeah. Totally get it. Totally get it. So, I tell you what, let me hang on. I know just the example for you. I know just the example. I just have to find it in here. There we go. Got it. Is that where they put the? I think they put that in the last one, right? Let's see. Okay, they put it in this one. All right, that's fine. Okay, so what I'm going to do here is I'm going to show you an example here, and I'll show you exactly how to do the ax plus equals b multiplication. Okay, and I'll show it off here with. Now, here's a quick question for you, Parrish. Are you allowed to use a calculator for this? Do you have like a TI 80? Do you have like a TI like 83, 84? Okay, cool. Perfect. All right, so if you have your 83, 84 out, we're going to use that here together, okay? So I can show you how to do that on your calculator, all right? But you have to set up the problem here first, okay? So if you got to show out the work, then at least you know exactly what you're doing, all right? So let's go over how we can set this up here first and foremost. All right, so let's set up some equations here. Yeah, that's, excuse me. All right. So let's see, we have x plus 2y plus 5c equals 2. What's your calculator, Parrish? I can show you alternatives just in case. There we go. Okay. FX 115 ES Cassie. Okay. Okay. All right, I'm going to send a link here, buddy. All right. So that there should help with the multiplication on the setting up the matrix there on the Casio. And we're going to do this problem here together so you know exactly how to essentially set up the matrices here appropriately. So let's go ahead and look at this together here at the very least. Oh, oops. Maybe it'd be helpful if you had noise. So, no, of course, man. I'm here to help. Of course. All right, let me start over here.
calculator for matrix multiplication. So to punch in matrix A, all you do is press setup, 6 for matrix, pick 1 for matrix A, 5 for a 2 by 2, and then just easily punch it in, 2, 4, -3, -1, oops, and then just press clear. Now to add your second matrix in, you have to press shift, matrix, 1 for dimension, and pick matrix 2. And the next one, B, will be a 2 by 1, so that's number 6. And 1, 2, and clear out of that again. Now to solve for the variables x, just press shift, matrix, then we go to matrix A. You want to take the inverse of that and times that by matrix B, which is 4. Now just press enter, and there's your answer.
All right, that was straight and to the point. I approve of this video. All right. Did that help? Nice. Okay. Well, let's do this problem here together, okay? Since you have your calculator and you have the video there, let's go ahead and see if we end up with the same results here. So let's just try it out with the problem here, and let's just confirm that you got the process down. So this is the problem that we have here, okay? The 3 equations, 3 variables. All right, now we're going to split this up into 3 parts, okay? So the 3 parts we split up, we're going to split it up into first the matrix here. Yeah, let's put in a matrix here. This first matrix is going to be a 3 by 3 matrix, which is going to take all the coefficients of x, y, and z. So we're going to have 1, 2, 5, 2, 3, 8, -1, 1, and 2. Our next matrix here is going to be a 1 by 3 matrix, which will represent the x, y, and z. And then that's going to put in equals, and then I'll have another matrix here for our answer matrix, which you see here on the right, and that's going to be 2, 3, and 3. Don't forget that this in your matrix here for your calculator, this is a 3 by 3 matrix here. Okay, again, 3 rows and 3 columns. In this case here, this is a 3 by 1 matrix, okay, 3 rows and 1 column. Okay, remember it always goes rows by columns, okay, on the calculator. That's even on the TI, it's the same thing. Even on your Casio, it'll be the same thing, rows by columns. Now, if we want to solve for x, y, and z, let's go to the next line here. If we are going to effectively, now this is actually kind of important because one of the things that you have to know about matrix multiplication is that order matters. So if you have this and you want to solve for x, for example, x has to equal A inverse. And notice that A inverse has to go on the left-hand side. So you can't switch it around. If you do B times A inverse, you're going to get the wrong answer. So you have A inverse times B. That A inverse has to come first. So in this case, we're going to take the inverse of this initial matrix. So we're going to take the inverse of this initial matrix here. So we'll put that up to the -1 power, which is how you'll have that in your calculator. And then you'll multiply that straight up by the answer matrix that you have here in this case. And wha-bam. So let's see if you got the same answer I did. All right, and let's see what we both get. And hopefully it will met out the way that it needs to, and then we'll be okay. So let's take a gander. So 3 by 3 here. Okay. Two, three. Yeah. B. All right. All right. So tell me what answers you got, Parrish, for X, Y, and Z. Once you have it, that is. Let's go back to the video here for just a moment. So he did mention that in the middle of the video.
You got negative 1, and then just press clear. Now to add your second matrix in, add your second and pick matrix 2, and the next one B will be a 2 by 1, so that's number 6. And 1, 2, and clear out of that again. Now to solve for the variables X, just press shift, matrix, then we go to matrix A. You want to take the inverse of that.
All right, so that key right there, that key he just pushed right there. Okay, so that was the x to the minus 1 key directly on the calculator. So you have to recall the matrix A. All right, so recall the matrix A and then just do to the minus 1 power just like that. Then you hit times and then recall the matrix B. Once you got that going, then go ahead and just give me your answer. So I got mine, but I just want to see if you got it right. Hopefully you got that, Parrish. Did you multiply it by matrix B? Did you set up a matrix B like I have here? So let me go back. You have to multiply it by this 3 by 1 matrix. It'll give you a 3 by 3 matrix if you take the inverse, but you then remember you have to multiply that matrix by the 3 by 1 matrix, which is the answer matrix here. So you All right, so let's try again here. So you have matrix A set up as this. Okay. Yeah. So let's see if you got the answer there. Hopefully we got it all put together. see here. Once you're ready with your answer, you can go ahead and post it in the chat, and I'll post it up on my screen. Okay, did you set up matrix B? Matrix B should be a 3 by 1 matrix. So all right, so let's look at the video one more time then. I think maybe we're just missing a step, but that's cool. Let's take a look one more time here. Just make sure that you got it all down.
Hey guys, just a quick video on how to use this calculator for matrix multiplication. So to punch in matrix A, all you do is press setup, 6 for matrix, pick 1 for matrix A.
Okay, so when you picked 1 for matrix A, you got the 3 by 3. I know you did that. And you should be comfortable how to get the inverse, so I know you're good with that. Right? Are we good so far with that? You got the 3 by 3 matrix in, no problem. Just want to be sure. We just go, kind of one step at a time to see where our error is. Okay, let's go to the next part then.
5 for 2, easily punch it in.
All right, you
Negative
plug.
1. And then just press clear. Now to add your second matrix in,
All right, now for the second matrix. It's 3 by 1.
you
So,
have to press shift, matrix.
so he goes shift and matrix, and he's going to hit number 4 for matrix B. So hit number 4 there.
One for dimension, and pick matrix 2. And the next
Oh,
one,
well, I guess he
and
picked.
the next
I
one,
guess he did it the other way.
and pick matrix 2.
So he picked a dimension first, and then he picked matrix 2 for matrix B. And here's 3 by 1 should be option 3 here. Did you do this? Did you put like 2, 3, and 3 for your option for your second matrix there? So just let me know if you got that matrix in there with 2, 3, and 3 in the 3 by 1 matrix. Just to confirm. Okay, cool. I'm gonna put the answer up here. This is what I got. So the answer that I got was -2, -3, and 2. That's what I have for my answer there, Parrish. X is -2, Y is -3, and Z is equal to 2. Okay, Samantha, no problem. I was just gonna email you, actually. I was wondering where you went off to. All right. So, it's okay, Parrish. Take your time. Take your time, okay? It's not a race to the finish. It's a matter of just trying to wrap your head around something that you're not familiar with. Don't worry about it. What questions do you have, Samantha? I know you have lots of questions, so need to be have you Samantha, have you tried all the sections? Have you tried some of the homework there from those sections? Better look at that there. Uh, how do I find the Okay, all right, that's fine. Want to be sure that we clue in on the key questions there. How do we find the multiples? So multiples are like, let's say I have 6, okay? Say, for example, I have 6, all right? And so if I want to find, say, the multiples of 6, all right, then all I have to do is just keep adding 6 every time down. So the next multiple of 6 would be 6 plus 6 would be 12. Then I add another 6 to that, which would be 18. And so on and so forth. The factors. Okay, let's talk about the factors then. That's okay. How we doing, Parrish? We hopefully doing okay. So again, reference the video I posted on the chat there. If you need to go, I would like look at that video and then just go through, like, start over and do like every button press he does on the video. Like, if that helps, then if it helps you kind of understand the process there, then that may be the trick there. So if you need to start over with the numbers that you see on the screen, yeah, start over with the numbers that you see on the screen just to make sure that you get these last 3 numbers here, because I want you to understand how to use that thing too. So, all right, let's talk about factors here, Samantha. Okay. So basically, factors are numbers that basically break that number down, okay? So think of it this way, we were trying to break the number down into 2 other numbers, okay? So let's take a number here like 20. Let's take 20, okay? So when we're trying to break this down into factors, okay, then we want to pick 2 numbers that we can essentially multiply together to get 20. That's what factors are. All right. So let's pick 2 numbers. What 2 numbers can multiply to 20? What do you think, Samantha? 2 numbers, when you multiply it together, would equal 20. Yeah, you can pick 10. 10 times what is 20? That's fine. Okay, good. So we're going to break it down into two numbers here. Now you said 10 and 2 is equal to 20. So that's fair. Okay. Now we want to break down 10 into two numbers as well. Again, 2 is a prime number, so this is where we stop here when we talk about our factor tree. So we're stopping with that branch because 2 is a prime number. Remember, a prime number is basically a number that can only divide itself and 1. So that's about it. Only 1 in itself can divide that number. So 2 is a prime number. It's the only even prime number that you'll ever get. Now 10 can be broken down further. We need two numbers that multiply together to get 10. What two numbers will do that? What two numbers multiplied together can get us 10? Very good. That's right. So we have 5 and 2. So we're going to put in 5. 5 is again a prime factor, and so is 2. So this is our factor tree for 20. Okay? So far, so good. Any questions about that, Samantha? Oh, okay. That was the problem there. Oh, gotcha. All right, Parrish, that is correct. Very good. You see that right on my screen right there. -2, -3, and 2. All right, good, good, good. That is absolutely 100% correct. Nice job. Now I hope that you're a little more comfortable with that process there. Let's try another one here. Let's try 80. Nice, nice, nice. Keep that video handy so that way in case if you forget. All right. All right, Samantha. How can we break up 80 into two factors? Yeah, I know. I agree. It may be laid out a little differently since I can't see your actual assignment. Um, but yeah, I totally understand that. We're not adding here, Samantha. We're multiplying. We want to multiply here. So like 10 times 2 is 20. I need two numbers that multiply to 80. So what number times what number equals 80? And you can start off with something basic. That's fine. Choose two numbers that you feel would be easy. So now, Parrish, you could probably make that adjustment with your homework and then be able to now do it. So hopefully it'll be a lot easier now. All right, good. 10 and 8 is correct. Good. Okay, let's break down 10 and 8. Hey, no problem. If you want to, hey, Parrish, if you want to come back anytime and you need more help, feel free to ask. I'm only here to help, man. I'm here on Twitch to help others. So, I mean, sometimes entertainment, but mostly to help with a subject that's usually rather difficult, especially with machines like calculators that can be a little tough to work with too. And if I don't know something, I'll look it up and I'll see what we can do. Okay, 4 and 2 for 8. I agree with this. How about for 10? Samantha. 5 and 2 for 10, okay. Can we, all right, so we're going to circle our prime factors. So 5 is a prime factor. 2 is a prime factor. This 2 is also a prime factor. Remember, 4 can be broken down further. Hey, no problem, Parrish. You take care of yourself, all right? You have a wonderful day. And weekend if I don't see you. All right? Remember, come back and ask anytime, buddy. You're always welcome. Two and two, that's right. So we got 2 and 2. Those are also prime factors. So we have our prime factorization for 80. 80 would be equal to 2 times 2 times 2 times 2 times 5. Okay, so that's how we break it down into prime factors. Now we can also see additional factors here. Okay, so let me show you what all the regular factors would be. This is the prime factorization. Now, we also talked about in chapter 3, not chapter 3, sorry, section 2.3, we also talked about the factors of certain numbers. So what if I were to take 80 and break them down into numbers that divide 80? Well, okay, so the first thing that we're going to do here, Samantha, is be like, okay, the first two numbers that always divide any number is 1 and itself. So we're okay there. Now we have to find the other combinations that make sure we get to 80. That's all we're trying to do. So let's see. We're just answering the same question here, okay? Does 2 divide 80? Let's just go up. Does 2 divide 80? Does 2 divide 80? So just a yes or no question. Does 2 divide 80, Samantha? Yes. So that's going to be a factor. All right, let's answer this question now. 2 times what equals 80? Because whatever 2 times that number is going to be, okay. Now that should be times question mark, sorry. Mobby. There we go. That's what it should look like. What number times 2 is equal to 80? Because that'll be another factor there. Not sure? 2 times 40? Okay. So Violette said 2 times 40. Now, if you're not sure, Samantha, what you can do is you can do 80 divided by 2. Because you know it goes in evenly, you just don't know by how many times. So you can plug that in a calculator there if you like. You could do 80 divided by 2, and you'll get 40 there. Okay? Any questions about that? Okay, perfect. Now, let's try 3. So on your calculator here, try 80 divided by 3. Does 3 divide 80 evenly? So if you get a decimal number, the answer is no. If you get a whole number, the answer is yes. Nope. Okay, let's move on to 4. Does 4 divide 80 evenly? Yes. So 4 is a winner, and 4 times what is equal to 80? What did we get when we divided by 4? 20. Perfect. That is correct. Let's try the next number, 5. Does 5 divide by 80? Okay, perfect. 5 and 16. Let's move up. How about 6? Does 6 work? No. All right, let's move on. How about 7? How about 7? Nope. Okay, let's move on. How about 8? Okay, good. So we get 8 and 10 as our next pair of factors. All right. And how about 9? No. Okay. Now, we could go on to 10, but we already have 10 in our list. So pretty much after this point, we are done because we exhausted all the possible pairs here once we start repeating. So these are our factors here of 80, all of these numbers here, okay? And you can see how we kind of broke it down just going one number at a time, starting from 2 and working our way up. So maybe you don't have a lot of numbers that are factors, but again, you got to test them out to see. That's it. Any questions about that? Okay. I hope that makes sense now, or at least that's making more sense. All right. What's your next question there, Samantha? All right, good, good. Okay, what does it mean when a pair of fractions are equivalent? Okay, so if a pair of fractions are equivalent, then that means that they can be expressed the same way, with the same exact numbers in the numerator and denominator. Or, again, think of it this way. Let's look at an example. And let's take a look. Let's take a look at an example here of like a pair that may or may not be equivalent. So, okay. So let's say I had 3/4, and I want to see if it's equal to. Oops, didn't mean to do that. I want to see if it's equal to, let's say, 15/20. Okay, I want to check to see if these two fractions are equivalent. Okay, now here's one of the things that can be helpful here in these two fractions. If we want to say that these fractions are equivalent, what we're going to look at is that right now as it stands, I have like a 4 here in my denominator, I have a 20 here in my denominator. I can't really compare those two because they look like two completely different things. You know, for us, it'd be like saying, okay, I can easily compare 1/3 and 1/3. They're the same exact number. They're equal to each other, right? That seems, you know, pretty straightforward, okay? So it's like, all right, you know, same context, same denominators, same numerators. Okay, great, that's good. So the key here in this case is to change the denominator, all right, to make it look like the bigger number here. So we're going to change 4 into 20, okay? So that's the key here. Key here is to have the same denominator, same bottom number. So now in order for me to do that, in this case, in order for me to do that, I need to figure out what I need to multiply by. I need to multiply 4 by something in order to get 20. So let's answer this question here. 4 times what equals 20? 5, okay? So what we're going to do here is we're going to multiply by 5 here, and we'll multiply this by 5 as well. We have to do for both. So if we multiply 1 on the bottom, then in order to balance things out, we're going to multiply stuff here on the top as well. Okay, so one of the things that we talk about in algebra quite often is balancing things out. So that's a very common thing to do. So let's multiply straight across, and let's look at both fractions now. So this fraction here, 3 times 5 is 15/20. And then on the right-hand side, we also have 15/20. So we could say for certain that these two things are definitely equal to each other. Okay. So that was an easy one. Okay, that was an easy one. Let's look at a tougher one here. All right. Yep. And okay, so let's look at both of these here. Actually, which way I want to go? Yeah, that's fine. That's fine. Okay. So maybe this is a little harder, okay? Maybe it's a little tough to get from 18 to 36, or maybe the numbers are a little bit different, okay? And that can easily happen in these problems, all right, without question. So maybe there's another way you could actually do this. So the other way to do this is, the second method to do this is to reduce both fractions. So we're going to reduce if you can. So what does that mean? That means in this case, let's say I reduce these two guys. Well, I know what's in common here is 2. So I'm going to divide by 2 here. And so this first fraction here is going to be 8/9. Okay? So if the other fraction also reduces to 8/9, then I know it's equal. If it doesn't, well, too bad, so sad. We move on with our life. Okay. So can you tell me here, what would I What 32 over 36? Well, what is a common factor between 32 and 36? What can I divide by on both the top and the bottom there to reduce it down? So 32 divided by 30? Remember, we want a common factor, a number that divides 32 and that same number that can divide 36. So 30 doesn't divide either number. Oh, I don't have that happen. 'What number divides 32 and 36? Sure, Toast, not a problem, my friend. Oh, okay. 4. That's correct. Good. 4 is spot on. Okay, so let's divide by 4 here. Sure, no problem, Toast. Take your time. So we got 32 divided by 4 here. And so we get 8. And we get 9 here. And as we see here, we get the same exact fraction here. 8 over 9. And that's what we're looking for there. Perfect. All right, great. Any questions about that? I hope that makes a little bit more sense there, Samantha. Yep, okay, good. Any other questions you want to ask? Okay, that's fine. Remember, we have a lot of time here, Samantha. This is okay. All right? I'm going to take your time and take it at your own pace. That's very important, okay? We have a lot of material, so I know that a lot of the things I talk about today is very overwhelming. So, please just, take it as easy as you can so you're not feeling very stressed or anxious or overwhelmed. That's why I have looser deadlines here in this class. No problem. Samantha, you have a very wonderful weekend, and email me if you have any more questions, okay? All right. Great. I'll see you later, Samantha. You take care, all right? I'll send you the notes soon, okay? Sure. How long it'll take? Um, you showed her my video, and she's curious on how long it will take to have a fun teacher in math. Well, you should always be having fun in what you're doing, Anna, and that's a very fair question. You should always have fun in what you're doing. The one thing that I find enjoyable is that if you can relate it to something that's real, usually people can connect with it in some form or fashion. Even if something doesn't have any relevance at all, at least have fun with it. You could say, oh, let's do conic sections and parabolas and blah 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 blah. And it's like, okay, that's I know it's not the greatest. I know it's boring, but you just have to learn to you gotta learn to live with a dry subject. So just have a little bit of fun with it. It doesn't take that long if you have the right attitude. And I hope your friend has the right attitude. Um, that's all it takes is just don't take it so seriously. I guess the one thing is that don't take it. She's a high school teacher who's been struggling, teaching for 3 years. Um, so what's she struggling at? I suppose. Because I mean, she tells you that she's struggling, but I don't know the specifics of what she's having a hard time with. So when you're a new teacher, there's a lot of things that you might struggle with within the first like year or two. So I could understand that. It's just a matter of um, it's a matter of what she's personally struggling with in her classes that I could possibly offer advice towards, to help her, you know. So I mean, it's a different situation because I teach college compared to high school, but yeah, there's certain things that you could do in high school and college that are pretty much one and the same. So, all right, she's trying to teach pre-calc, algebra, and econ. All right, so those aren't too bad. Okay, but what does she complain about the most? Although those are the subjects that she's teaching, there might be more details to that, like student interaction or specific details like that. I mean, a lot of times when it comes to teaching, it comes to like kind of the background details. It's like you know the subject, but you have to be able to kind of express it to others, and that can be difficult sometimes. She cannot fill the 50 minutes for her students. Her classes ended up being 20 minutes. Okay. All right. I see. So she feels like the material, does she feel like the material is too easy for her? Now, I'm just gonna be, I know I'm gonna ask a few questions here, but I want to gain perspective here. Does she feel like the material is too easy for her to do? Because when you take 20 out of 50 minutes, then, I'm, I'm I guess what I'm trying to say is that if she feels like the material is too easy for her, she has to kind of change the perspective kind of away from, like, for me, I don't I change the perspective. For example, I know pre-algebra like the back of my hand. It's pretty easy, but the thing is that I have to make the assumption that everybody else does not in the class. They have a tough time, and I have to speak through their perspective and their lens as opposed to my lens. Yeah, I try and not waste. There's not a lot of waste time. I agree with that. I agree with that, Anna. Like, I guess for her is like again the one thing that I can totally suggest to your friend, and if she feels like she's struggling in terms of time, and in terms of content and things like that, I could make some suggestions here. So let's go down kind of a list here. So first thing is sometimes slow down. Just slow down. Like even in the most complicated class that I teach, for example, like calculus, that's the highest that I teach. I sometimes have to slow down, and it's not just for me, but it's for the students because the in mathematics the devil's always in the details. So sometimes you have to be very articulate about the details that you want to express while you're teaching that subject. So just slow down and go at a slower pace. Remember, I understand that if you want to get things done fast and boom, 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 but some students are going to get lost behind because you went a million miles an hour. Now I don't know if that's the case, of course, but what I do know is that if she's feeling just kind of slow, if she feels like everything's going by really fast, maybe slowing down is just one of those things that she needs to do right away. The second thing, of course, is more examples. Um, more examples. That, of course, kills time. That's pretty common. Um, more student interaction. That's one of the other things. So this is kind of like what we call a flipped classroom. She can certainly try that, where she takes students, she teaches the concept, but then uses like some technology or something like that and has them work on problems, and kind of have them teach each other in the middle of class. So that's one way you can kind of take up the time during that time. So if you make up a large enough worksheet, then that should be just fine for the class there, just getting concepts and problems over. So that's very good. Uh, Another thing is current events. Now you're probably saying, well, hang on a second. What do current events have to do with this? You know, um, you'd probably be surprised, but I keep myself aligned on current events of what's going on in the world today. But this isn't just like what's going on in the world, just in like politics or something like that. I'm talking like pop culture or other fun things to do. You keep yourself up to date. You don't have to keep yourself up to date with everything, but certain things will be good, like catching up with a little bit of slang. So sometimes students may say something you don't understand it, but if you keep up with the slang just a little bit, then you can talk to the students at a much more relaxed level. And students are technically a little bit more. I guess the best way to put it is they're a little bit more receptive and they're a little more chill. When you talk, when you can talk the talk a little bit. You know, um, the second thing, yeah, I guess, so it really helps out a lot just to have those current events. It really helps you build that rapport with your students, and for honest reasons, it really makes the time fly by when you're having fun. Because if you're just sitting and chilling and talking with your students while still teaching a subject, you know what? There's then those 50 minutes don't feel those 20 minutes, they fly by really fast, and suddenly you're actually done with the whole 50-minute class, and did the subject there. If you need to do an aside, for example, go off on some story, okay, that's fine too. That's not a problem. So that's another thing that I can make a suggestion for your friend there in high school. I know there's a lot of red tape in high school, a lot of politics in high school, but at the same time, uh, you know I don't worry about half of that stuff, obviously, but thing is that, keeping up to date is never a bad thing. Now, I don't make many lesson plans. Instead, what I do is, and this is an important thing, adapt to students, not to the lesson plan. Although you have objectives to do in each one of the classes that you mentioned here for your friend, for algebra, pre-calc, and economics, you need to adjust yourself to the students and their level of understanding. So reading, I'm pretty sure your friend is very good in reading body language. That's very important. So reading the body language of the students is more important because then you can adapt to them and not to just get through your lesson plan every single day. I know people have a pace, but sometimes, like I said, it's good to slow down, and it just means if you fall behind a little bit, you'll catch up a little bit later. And but at the very least, the students will be all on the same page with you, and then that way you'll feel a lot better for the productivity you put in for that particular class period. So that's another thing to keep in mind is that a lesson plan's okay, but a lesson plan is very inflexible because of the fact that it doesn't take into account the many types of students that you have in a class. So I'd rather hear from the students. That's why I ask a lot of questions often. I want to hear from the students. I want to see what they understand. And if it means that I have to go slower, then okay, so be it. It is what it is. So, that's not too much of a problem. Um, yeah, that's how I feel about that because yeah, it can be very overwhelming at times and it can, feel sluggish, but the more you're receptive to the students, then the more they'll be receptive back, and you have a lot of fun doing it. All right, and finally, just be silly at times. Yeah, it doesn't have to be. Just be silly, have fun. Just smile, enjoy yourself. If you really enjoy this, then you'll never work a day in your life, and you just sit here and have fun. Just have fun. Just be silly. It's fine. It's fine. Students don't like seriousness all the time. It's very boring. I think everybody doesn't like seriousness all the time. It's like if, you know, a lot of a lot of stress. So the moment you relax and put that stress aside, everybody will hopefully join you in that same endeavor, that same attitude. So I hope that those are some some helpful advice for your friend there. Because I feel obviously, you're always improving, you're always trying your best, and you're trying to, be a better teacher. I know she's doing her best. So, you know, but if it means making some adjustments, okay, great. These are some adjustments that you can certainly make. I don't know if you have anything else you'd like to add there, Anna. I apologize, I kind of talked a while, but I wanted to answer your question thoroughly. She's also in grad school. Yeah. So if she's also in grad school, when I was in grad school, that's still the same attitude that I kind of had. I had the same attitude because I taught in grad school too, for 3 years, and I was just silly and fun, and I just enjoyed myself. It's like that. That's what it was. I know she's doing a lot of research at the same time. Also taking her grad school classes. And yes, that's a lot of work, but that's the balance that you have to kind of put in. But I could tell you right now, if she starts to have a more relaxed attitude toward, doing the teaching aspect and not think it's, super serious all the time, just take it at a pace that she's comfortable with and not feeling overwhelmed, then she's going to feel a lot better at the end of the day. Because it certainly sounds like you care about her a lot. So, I mean, and I would want the best for her too. So she's not pulling her hair out or stuff like that. and you want to see her better as well. So I don't know if you have any questions there, Anna. You could ask me whatever you like, though. It's all good. Well, that is well, okay. Um, as her friend, I think an important question you should ask her is, and it's this: ask her this important question. Say, it's not about continuing teaching. It's just, do you enjoy teaching? Do you have fun in teaching? Or do you feel like if you went in another direction, you could really find your purpose? That's the question that she has to answer. And I think it'd be a good idea if you actually ask her that. Give her something to think about. She may not have an answer for you right away, and that's fine, but if she really enjoys the teaching aspect, if she really has a lot of fun, okay, great. Then keep continuing to teach after grad school's over. But if she wants to do something different with her degree and she wants to go off doing something else because she feels she would enjoy that and get the most benefit out of what she studied and learned, okay, that's just as fine too. So, you know, it, obviously, she, just depends what her attitude is, going toward both things. Is her dream, kind of teaching or is, helping others? It's kind of like she wish she could work like she can if she wants to. If she wants, it's not a lot of look. I can tell you, I don't put in a ton of effort, but you know what? I've been doing this for like a long time too. So to be fair, I've been teaching in some capacity for like 17 years. So um, it takes a lot of time, but and I'm glad she had a lot of fun watching my video. Believe me on that, I really do. But at the end of the day, um, if she emulates me, that's the sincerest form of flattery. Says, that's very kind of her. But I want her to pick. Yeah, I want her to pick her own path. Her own path is the most important path. Uh, and if she has the same look on her face as I do about teaching, like if she's doing accounting or crunching numbers, and if she has a lot of fun doing that, because that's what she feels fulfilled about, then and she has the same look as I had, in that video, then she's doing something right. It doesn't have to be what I do, but it has to be something that she is actually legitimately like passionate about and something that she would enjoy. Maybe later on she goes back to being a teacher, part-time. I had some colleagues who worked corporate jobs and then did teaching at night, whatever the case may be. But that's her decision ultimately at the end of the day. Uh, that's the best advice I could give. I want everybody to choose their own path for the reasons that they feel. And if you feel like, hey, I'm having fun, enjoying, hey, good. Then we're on the same level. We're on the same equal plane here. No difference. Yeah, that's fair. It is easier to be a community college math teacher than it is for high school. I agree with that. I agree with that. Yes, and that's because for me, there's less politics, so I can just do what I feel would be, good for the student and stuff like that. There's less red tape. Yeah, no question about that. But that's why that's a question that your friend needs to answer at the end of the day. You know, I don't want to be the person that decides a person's future. I'd rather be the person that tells you the questions about how to determine that. That's a lot better. And then you can answer that for yourself. And you could tell your friend, be like, whatever path that she decides to go down, no matter is if it's continuing in high school math teacher, or doing a job in the corporate world, if she feels comfortable with that, she feels happy with that, I'll be happy to support her 100% with that decision. I'm just hoping for the best for your friend, really. Like I said, I hope my advice will be good for her. That's good. That's good. I'm glad you're picking up something. I know you come into like some of my other classes too, just to kind of brush up a little bit. I appreciate that very much. I'm glad you're learning something along the way. I had no idea how this was going to turn out when I actually had a full-time online thing on Twitch. I had no idea how this was going to turn out. But I've met I met you, and very wonderful people here online. I'll really appreciate the time you guys actually make to come out to this little corner of the interwebs. I'm a bit of a gamer, but you know what? I totally understand. Uh, this is their first time on Twitch. Well, there you go. Random happenstance. It happens. Probabilities. There you go. Oh, this was something you could watch. Okay, that's fair. Yeah, absolutely. If I'm glad this is I'm glad this was tolerable. That's good. I I, uh, I apologize if I go off the rails a little bit sometimes when I'm doing lectures, but no, I do sincerely appreciate the fact that you come out to this channel in this neck of the woods. I try and make it as enjoyable as I possibly can. So, you know, when you're doing something that can be as boring as this sometimes, sometimes you gotta spice it up a little bit of salt and pepper, there you go. Sort of deal. I don't know if you have any more questions, Anna or Violette or anyone else in the channel. Uh, if you guys have questions, I'll be happy to answer them for you, or at least something that I could help you with. I hope that my advice will be helpful for your friend Anna. No, no, it's all good. Don't worry about it, Anna. If you have a if you wanna chat sometime, just feel free to chat. It's fine. Don't worry about it. I always have an open ear. So, you know, there's things you need to talk about. That's what I'm here to do as well. So I may discuss about math topics, but that's not the only thing I talk about. Trust me on that. If anything's like, if anything's bothering you, if anything, like to talk about, like advice, things like that, I'm a veritable punching bag for that stuff. So, you know, I don't have a problem with that at all. If you need to just kind of vent, that's cool too. I like that. If you have a goal and you feel like you persevere, that's good. You work hard and you get the rewards from working hard and getting somewhere. I think that's a wonderful. Absolutely wonderful. Trust me, I would like you to get to whatever your goals are. I would love to you to get there. All right. Great. You know what? That was 9 years of hard work and you got it. And you should be congratulated for that. Congratulations on that, by the way. That's wonderful. Absolutely wonderful. That's something you worked little by little for, and you eventually got to where you wanted to be, and you got that goal, and that's really, really good. The one thing I always say is like, never compare your journey to someone else's in that regard. It's like it may have taken you 9 years, but that was your personal journey for those 9 years. I hope so too. I really hope that the teachers, yeah, I hope that the teachers that you had made a change in you and vice versa. Everybody can learn off of each other a little bit. I think that's very important. That was my goal actually, to be honest. And my goal was very simple, was to when I was in grad school teaching for the first time. I didn't know what I really wanted to do at that point, but I was like, okay, I'm teaching because I have to. And I'm like, well, what's my goal at the end of the day? When this is all said and done. And I just had a simple goal. My simple goal was to change one person's life, and I said that's all I want to do is to change one person's life. And through those 3 years, that I accomplished that and then some. It may not be the highest bar to go, to set a goal at, but it was at that time where I didn't feel, very confident about myself. And I was like, I didn't feel very, like I felt a little worthless and things like that. That was kind of a tough go at the time. But, the more and more I started teaching, the more and more confidence I started getting. And, then I was able to affect more than just one person and just say, well, everything else is just kind of gravy, after that. It's just, delicious stuff. Ah, man, that's not nice. I'm sorry you had to go through that. Yeah, I'll admit one thing. Yeah, they were fighting you in the, man, why? That's so pointless. Like you're trying to get an education. Why prevent you from doing so? That seems so silly. You're willing to pay them money to go into a course and then they're telling you no. Like, I think that's ridiculous. Prerequisites one thing, but if it's just a regular course, then why? You know? Doesn't make sense. I'm sorry you had to go through that experience. That probably should. It sounds like it was a bit of a mess for a little while. Well, I could tell you one thing in this stream, Anna. Uh, yeah, you don't have to fight with anybody to be in the stream. You can come on by anytime. I got no problem with that. Ugh, yuck. Wow. Yucko. Man, that's rough. You know what though? It's as you say. You persevered, Anna, and that's what counts. You persevered through all that nonsensical BS and you got what you earned. You're afraid to go back to school? Well, I mean, that's one community college, but that doesn't mean you should be afraid. That's just maybe that one place. I think I can understand how that experience could have affected you. I'm not going to discount that at all, but remember why you would go back to school if you wanted to then anyway is to, better yourself. Everybody has different goals when they go back to school, but if you're using your associates now to, in business at a job, then great. You did exactly what you set out to do. If you want to go further than that, then that's of course your choice and what your goals are at this time. Since it's been 5 years after you graduated, so it's totally up to you what you want to do if you want to go back and learn more. But maybe not go back to that community college because sounds like sounds like you just a tough time with the circumstances over there. You can go out of district. It'll cost you more, but at the very least, it may prove to be a bit smoother. Okay, I know for a fact, Anna, that the ADA, like the ADA office, is a lot better than it used to be. Like if I were to compare 5 years ago and today, it's a lot better. Like there are more resources available than there were 5 years ago for sure. So I mean, like I've had deaf students in my class, and we had the interpreters there. When I was teaching the in-person class and stuff. Some with a few learning disabilities. Just kind of working with their accommodations and whatnot. I felt that some community colleges, were very flexible with how they were able to help students and whatnot, and that they were able to work with the issues that students with disabilities had, and I found that to significantly improve ever since I started and until now. So I've been working at the same like couple of schools for 10 years, and I've seen a noticeable improvement within the ADA stuff. So yeah, I know. I mean, can't change the past. We can't change the past, Anna, but you are working toward a future, and I think that's just as great. We could, yeah, we can lament about what happened in the past, Anna, but you know what? We're looking forward. We're looking ahead. right? Those things have happened. They're done. They're over. We can hope things will get better. And you know, I've seen the ADA office do a lot better on campus than they have been before. You know, I I don't know your full set of circumstances, but that's okay. But you know what? It was all for your own future, and you got exactly, it took time, but you know what? You got it, and for that, you should be very proud. You weren't about to let somebody, bring you down. I think that's wonderful. I think that's absolutely wonderful. I think that's wonderful. That's great. We definitely need more people like you. Absolutely, 100%. I think we need more people like you than maybe people like me. I'm just a regular dude, But no, you put in the time, patience, and effort, and everybody who I've worked with from the ADS office on my campus, they are they are such hard workers. They're so wonderful. I appreciate all their help. I always get along with all of them because it's just a matter of just thinking through their perspective and how patient that you have to be at times. And it, sometimes it could be a little stressful, sometimes not, but that the payoff in the end is really, really good. So, you know, there's there's a person with a possible disability that has a chance to move forward, that has a chance to be better. And that's the ultimate payoff. That's the best payoff right there. And if we can facilitate that, then we know that we've done the right thing and we know that we can feel fulfilled at the end of the day. Thank you. I hope you do too. The feeling is very mutual, Gana. Feeling is very, very mutual. I can tell you that. If you can be that icebreaker, I hope I can be that icebreaker as well. I have a very simple philosophy, at least with students with disabilities. I understand that they may have a disability, but the one thing that I do is I make sure I treat them as equally as all the other students in my class. Doesn't matter if you have a Doesn't matter if you have a wheelchair, doesn't matter, anything at that. I'd be a great guest speaker for that'd be really kind. I mean, maybe I should do that someday. But it's just, doesn't matter what disability you have, if I treat you as an equal, then and still being respectful, of course, with the things that your disability and whatnot. I don't think that's that hard to do. I don't know why some people find that hard to do, but it really isn't that hard to do. It's just understanding something's there, but it doesn't mean I treat them any different, like lesser or feel pity on them. No, not at all. They want to learn a subject, I'm going to teach them that subject. I'm going to help them as much as I can. I just have to work around said disability, but that's fine. That, you can adapt to that. I don't think that's too hard to adapt to. You just have to have patience and time. Sometimes I feel some people don't have that, and I'm like, well, why not? They're asking for help. Aren't you going to help them? You know, I don't know. Sometimes I feel that way, but most people I've met are not like that. Wow, very nice. Very nice. That's awesome, Anna. You should be really proud of yourself. You definitely did persevere. Well, let me say this, like I'll say before. You were the speaker. You were the speaker for Virginia Education and Disability Act in 2006, 2007. Wow, wow, that's really amazing. Wow, that's really amazing. I'm glad you stood up for. Wow, that's very impressive. You stood up for education rights for you know underneath ADA. I think that's amazing. That's great. That's leaving a long lasting impact if you were able to make a change like that. That's awesome. I can't even imagine how many people you helped by just being part of that. I think that's great. You don't see any students after me go to college? Oh, I see. Yeah. I would at least for me, I would want to change like the high school system. I would like to give people an opportunity to go to college and stuff like that. So I don't know how it is in your area, of course, because your areas could be very obviously different from me. I live in the suburbs of Chicago, so obviously very different. But you know, uh, yeah, I would want to give everybody an opportunity to go to college and things like that. I agree, 100%. I think there could be an opportunity there if we change the system up a bit. I think that there'd be an opportunity there. The system is not greatly conducive at the moment. It needs to be better, in my opinion. It needs to be better. Where is the name of that? Well, currently I was teaching in Illinois. I mean, I live in Illinois, obviously, but yeah, I'm teaching obviously, as you can tell, I'm teaching in my place right now. So yeah, I was teaching face to face, and then obviously pandemic hit. So yeah, I've been doing this for since the pandemic hit, and just staying in my place for a little while. I have a lot of fun. Even if it's in my house, I gotta figure out a way to pass the time. So that's what I do. All right. Okay, it's 2 o'clock here, so yeah. I mean, with the current way things are, that's not surprising if it's teaching from like somewhere else in North Carolina. I mean, I guess we shouldn't be surprised. I guess that would happen. All right. Well, this is where I have to head off here for a little bit. I'm gonna go grab some lunch. Um, I want to thank you. Uh, no, it's okay. It's okay, Anna. You're all right. You can always speak with me. It's not a problem. I'm gonna go grab some lunch though, and I'm gonna be back here in a couple hours at 4 o'clock. So if you want to come back then, Anna, you're more than welcome to. I have no problem with that at all. Um, thanks for talking. I really appreciate it, and I've learned a lot here today from what you've been through. I think that's awesome, and I don't know if I can hold a candle to you, Anna, but I hope that I can cut the mustard. Cut the mustard sometime. That's what I'll try and do anyway. I'll try my best. All right. Thank you very much, everybody. Please take care of yourself. All right. I'll be back in a couple hours at 4 o'clock for some college algebra. All right. College algebra. All right. Have a great one, everyone. We'll see you then. Take care of yourself. All right, everybody. All right. Bye.